All right, so I'm trying to help you with using Pascal's triangle to expand a binomial. And the first thing I want to make sure you understand is what you're really doing here. So what are we doing? Well, if we had x plus 2 squared, we know that that is x plus 2 times x plus 2. And if we do that, we do x times x is x squared. X times 2 is 2x plus 2x, so that's plus 4x plus 4. And that's not so hard to do, and when we just see this 2 up here and we square it, it's not so bad. All right, but if we keep going and we say x plus 2 cubed, well, now we have x plus 2 times x plus 2 times x plus 2. We already know, we just did what these two are, right? These two are x squared plus 4x plus 4. And then we have to do times another x plus 2. So now we're at x cubed plus 2x squared plus 4x squared plus 8x. Now I'm on the last one, I'm multiplying this times everything, so plus 4x plus 8. So we have x cubed plus 6x squared plus 12x plus 8. Right? And if I wanted to do that again, if I kept going, if I said, I'm not going to do it, it's not the point of the video, to the fourth, well, this would be x plus 2 times x plus 2 times x plus 2 times x plus 2. We know that this is, right, we use a different color, we know all of this is all of this, and then we have to multiply it again. And you can see how tedious this gets. And so somebody said, let's try to figure out a pattern to this. And somebody way cleverer than myself came up with this idea of using Pascal's triangle, that the pattern is going to help us figure these out. So from Pascal's triangle, we start with ones, right? And then we always have a 1 on the outside, and we start adding these middle terms. So 1 plus 1 is 2. We keep the ones. 1 plus 2 is 3. 2 plus 1 is 3. 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we have to think about, okay, so, and this is weird because even I sometimes forget this. This is going to be, I got to check. It's all right, I'm going to check. It's okay, this happens sometimes. I'm looking for where Pascal's triangle starts. See, I've forgotten something. I'm old and it's in the morning. Pascal's triangle. All right, so row 0. That's what I was thinking, that it started with 0. That's what I was checking, and I wanted to double check that I was right on that. So this is, we normally start counting at 1, so I was thinking, this is row 0, row 1, row 2, row 3, row 4. Well, how do these work with what's over here? If this is squared, this is going to this. This is the row that's going to help us with squareds. All right, if we're cubed, this is the row that's going to help us with cubed. So let's just do this x. We already have this x plus 2 cubed done the old way. Let's try to do x plus 2 cubed with Pascal's triangle. So x plus 2 cubed. How is Pascal's triangle going to help us? Well, these are the coefficients. Okay, so I'm going to use 1, 3, 3, and 1. Those are going to help me. Now, what do I do with the rest of this stuff? What is in this position is going to start at this power and is going to go down. So, and this is all multiplication. So this is going to, what color? Let's use green. I'm going to use green for this one. It's going to start at the third power and it's going to go down. So this is going to be x cubed. Now I got to go down. X squared, x, and we don't write x to the 0, so I don't need to put anything there. Now I'm going to go the opposite direction with the second number. This is going to start at 0, which 2 to the 0 power is 1, so I'm not going to put anything there. right? This would be 2 to the 0, and that equals 1. So I'm multiplying. I don't need to put that at all. Let's actually not even keep it here. All right, so now I'm going to say this first space was 2 to the 0. The second space is going to be times 2 to the first power. Now I'm at 2 squared times 2 squared, and the last is times 2 cubed. I go all the way up to whatever that power is. Now, what's in between these depends on if we have pluses or minuses inside. We're going to be very simple. Problem I gave you is pluses. So in between these terms go pluses because we have plus. If we have minus, they actually alternate, plus, minus, but we could, let me just quick, we could, if this was x minus 2, we could write this as x plus a negative 2, and then the power of these guys would control whether this was positive or negative, so that's how you deal with that. We don't have to deal with that right now. So now we just need to simplify. 1 times x cubed is just x cubed plus 3 times 2. This is all multiplication, and remember we can multiply in any order. So this is what you're really doing, is you're just multiplying, you're just having these numbers written and not simplifying. So I have 3 times 2 is 6 times x squared. I have to just leave as x squared. Plus, this is 2 squared. 2 squared is 4. 4 times 3 is 12, and I still have that x. 2 cubed is 8, times 1 is still 8. Now let's check. We were comparing it to this one, right? X cubed plus 6x squared plus 12x plus 8. Okay, so we get the exact same thing there, and it just makes it a whole lot faster. All right, let's do one more. We got to kind of clear out this space here, and we'll do one more to see how it works. Now let's say I have x, I don't know, plus, I don't want the numbers, let's just make it, 1's too easy. X plus, we can even do, let's do x minus 3, and let's go to the 5th power. And now we see we don't have enough rows here, so we can keep expanding Pascal's triangle. 1 always goes, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then we have a 1. And this is our 5th row, and we need the 5th row because we have x to the 5th. All right, so how many, these even tell us how many spots we need, right? So we need 1, 2, 3, 4, 5, 6 places. 1 and 2. We're going to go ahead and keep the plus between them, and we'll deal with that minus. 1, 2, 3, 4. I'm not going to have enough space. I'm going to go down here further. 1, 2, 3, 4, 5, 6. All right, and now these, we need these numbers, right? We need the 1, we need the 5, we need the 10, we need the 10, we need the 5, we need the 1. All right, and that's the same. It doesn't really matter. You can see it doesn't matter what's in here yet, because Pascal's triangle is helping us with these coefficients. So now let's deal with x. We're at the 5th power, right? So because we're at x to the 5th, we're going to start with times x to the 5th. Now we're going to just go down. X to the 4th, x cubed, x squared, x, and here x to the 0 is 1, so I don't need to write, right? X to the 0 equals 1. 1 times 1 is 1, so I don't need that at all. Now I have to deal with, this part here, and we could rewrite this. This is the same thing as x plus a negative 3 to the 5th power. So the thing I need to work with is negative 3. So negative 3 to the 0 power still equals 1. So I don't need to write anything here at all, but I do need to come here. It's going to be negative 3 to the 1st power times negative 3 here squared times negative 3 cubed times negative 3 to the 4th times negative 3 to the 5th. And I know I did it right because I got 5th and 5th. Okay, so now we just have to simplify. 1 times x to the 5th is still just x to the 5th. Negative 3 to the 1st power is still negative 3, and this is where that minus is going to come in. All right, so I have to put minus instead of plus. So negative 3 to the 1 is negative 3. Negative 3 times 5 is 15, and I have the negative there because I have minus. So I need 15 x to the 4th. Now, negative 3 squared is going to be 9, and that's okay because that's positive. So I have a plus. 9 times 10 is 90. 90x cubed. All right, again, negative 3 to the 3rd power is negative 27. So I'm going to need that. I'm going to, instead of saying plus a negative, I'm going to leave it negative. 27 times 10 is 270. X squared is still there. I can't multiply it because I don't know what x is. Now it's going to be plus again. All right, 3 to the 4th. So this is 27 times 3 more. So 21. 681, should know that. I still have to multiply it times 5. 81 times 5. 5, that's 40. 405. 405x. And then we have negative 3 to the 5th power. Means I got to keep that minus. And I have 81 times another 3. So that is 3, 20, so 243. Okay, and these, what I was saying is it alternates because this is always a odd, even, odd, even. That's why these alternate, negative, positive, negative, positive, negative. And that's a pattern. Okay, so Pascal's triangle is helping us to, we use the word expand binomials, but expand is just meaning by multiplying them, however high their power goes. All right, I hope this will help you get the problem you're working on.